What is the velocity here? Here the velocity say is V. The total energy here and total energy here must be same by energy conservation. Here and here the total energy must be same. Here the total energy pure kinetic of mv square. Here there is elastic collision and between identical body. Then what happened? They will exchange their velocity. They will exchange their velocity. That means on hitting, this will carry the velocity of A and move with the velocity of A and reaches here and takes circular motion. We have heat equation is mc delta theta. M is equal to 40. See the specific capacity. Specific capacity is given to you as 81 calorie per kilogram. 81 into calorie per kilogram. Calorie. Joule per kilogram we are required into 4.2. This is the question from work power energy. In the case of a vertical circular motion of a particle by a thread of length r, if the tension in the thread is 0 at the end angle 30 as shown in figure, the velocity at the bottommost point A of the circular path we have to get. What is the velocity here? So that on reaching here, the tension is 0. Tension 0 means the mv squared by r is balanced by the component of the gravity towards the center. That's okay. If we draw the figure again, from here we project so that body reaches here. This angle is 30. Here, if V dash is the velocity or V dash is the velocity here, then the outward force is called M R or mv squared. mv squared by r. That is, suppose this is 30, this is 60, and this is mg. So this component is called mg cos 60. Here the body is said that not apply any action at this point because the tension on the string is 0. Tension on the string 0 means tension is caused by mv squared by r minus mg cos 60. That is the tension. But the tension is 0. So tension 0 here means m v squared by r at that point, v dash, v1 v dash. M v dash squared by r is equal to mg cos 60. From this, v dash square is equal to m cancel out rg into cos 60 is equal to rg by 2. Or v dash is equal to root rg by 2. At this point, you got the velocity of the particle. So that the tension here is 0 or it is not applying any normal action on that. If it is of a sphere or something. Or there is no tension on the string, condition is this one. Next. If this is, how much is the radius? R. Then what about this side? This is equal to 30. This is equal to r sine 30. R sine 30 is equal to r by 2. So this is r by 2, this height. This is r. Now what we are going to do, what is the question is, what is the velocity here now? What is the velocity here? Here the velocity say is v. The total energy here and total energy here must be same by energy conservation. Here and here the total energy must be same. Here the total energy pure kinetic of mv square. At this point, put that point at A, total energy is equal to half mv square is equal to total energy at what is the point? We didn't give a name. Here the point C. At C, total energy at C. Total energy at C mean half mv dash square, where v dash is velocity at that point, plus the gain in potential energy mgh, h is equal to r plus r by 2. mg r plus r by 2. M cancel out. So from this v square is equal to v dash square to cancel out rg by 2 plus 2g multiplied by 2 g r plus r by 3 by 2 r is equal to 3 rg plus rg by 2 mean 7 by 2 rg. Therefore, v is equal to root of 7 by 2 rg. 7 by 2 rg, there. Question. Option is 1. So we apply the energy conservation and get the answer. Next one. A bead P is sliding on a frictionless semicircular string ACB, and it is at the point S here. It is at here. At t is equal to 0, and at instant horizontal component of velocity is p. That means along this. Here is horizontal velocity is v. Here horizontal velocity is v. It has got effective velocity more than v along the tangent. But here the horizontal velocity is v, and starting from here when t is equal to 0. Another bead Q of the same mass, its instant horizontal component of velocity is v. Not the total velocity, horizontal component is v at this point. That means as it moves here, the horizontal velocity increases because of the gravity effect. And here it has got the maximum velocity here, much more than v. Again decrease, and on reaching here, again the velocity will be, thereafter it may decrease. It's okay, horizontal velocity. That means throughout the journey from here to here, its average speed is much more than v. Agree with me? Here is v, increase, and here is much more than v. On reaching here, it is again v. So here the velocity, average velocity much more than v, average horizontal velocity. Whereas hereafter this may be less than v. But overall, if you take the velocity, average horizontal velocity is more than v through this journey. Throughout this journey, the average horizontal velocity more than v. Argument is clear. Next part, it is what it says. Another bead Q of same mass P ejected from A from here along this direction with the same velocity v. Friction between them, etc. neglected. Let Tp for this particle, Tp first particle, and Tq for this particle. Time taken by the bead P to Q, P and Q to reach that point B. From here to here, time taken is equal to Tp. From here to here, by this particle is Tq, which is greater or which is less. This is what is asked. Then the relation between Tp and Tq. Here, the average speed is much larger than v. Here throughout is v. And therefore, time taken to cover this distance with a horizontal speed or average speed is larger than v. The time taken is less. Therefore, Tp will be less than Tq. Tp less than Tq. That's okay. Argument's sake, we can get it. because here the horizontal speed is much more than this one. Major part of journey, horizontal speed is more for this particle, and therefore time will be less. Therefore, Tp less than Tq. Okay. A small bob A of mass m is attached to a massless rigid rod of length 1 meter. Massless. We are not bothering about its energy factors. Then pivoted at the point P and kept at the angle 60 degree here. With the vertical as shown in figure. At a distance of 1 meter below the point P, a nickel bob B is kept at rest on a smooth horizontal surface, this one. That the extend to a circular track. So if it will take a circular path on this track. Radius R as shown in figure. If the bob B just manage to complete the circular path, it is just complete the vertical path and fall. So okay. Circular path of radius R up to the point Q. That we need to take up. It is just negotiate vertical circle. That's okay. On reaching here, it will move along the tangent. That's okay, because the frame is not there. But the problem is that it is taking vertical circular motion, and minimum speed is required at the bottom is attained. That's okay. Or just to complete vertical circular motion, what the minimum speed required at the bottom? Minimum speed required at the bottom. Minimum speed required at the top. Root of Rg. Here, what the minimum speed required at the bottom is equal to root of minimum speed required here, so that it will take up negotiate the vertical circular motion. Root of phi Rg. Here is equal to root of Rg. Here there is root of phi Rg. Minimum speed required, so that it take up vertical circular motion. Then find the radius. Now what we are going to do? Here there is elastic collision and between identical body. Then what happened? They will exchange their velocity. They will exchange their velocity. That means on hitting, this will carry the velocity of A and move with the velocity of A and reaches here and takes circular motion. But instead of saying so, what I am going to say, well, that is what is happening. Now, due to this purposely elastic collision, whatever energy lost by this body when it falls from here to here, when it reaches from here to here, it has potential energy. That potential energy is gained by B and reaches here in the form of whatever potential energy lost here is the kinetic energy of this body at this bottom. That due to that kinetic energy, it has got velocity, how much root of phi r, so that it take up vertical circular motion. Or the total energy of this B on reaching here and total energy of the body here are the same. And here it is doing just vertical circular motion, means speed at the top is equal to critical speed root of Rg. But at the top, speed is equal to root of Rg. The bottom, it is root of phi Rg. And here, if you write down the total energy, our total energy at here I am saying x and here it is y, the top. Our total energy at x equal to total energy at or the total energy at x of p square. What is the velocity required at the bottom to take up vertical circular motion is root of phi Rg. Phi Rg square. Total energy at y means potential energy. Potential energy is equal to mg into 2r plus half m p square root of Rg. But from where this body has got this half root phi Rg whole square kinetic energy. the loss in potential energy of A on heating on B. But total energy of this body is the energy of this body, loss of potential energy of this body. So this is same as loss in potential energy of A is the gain in kinetic energy of B to B, which is same as the gain in kinetic energy here. Therefore, I am saying loss in potential energy of A is equal to total energy here. So I'm doing is equal to 2mgr plus half mg. Now, what is the loss in potential energy of A? Here, this is 60. This is 1 meter, and this is 1 meter, and both this is equal to 1 cos 60 or half meter. Therefore, this is half meter. The loss in potential energy is equal to mg into height. Loss in potential energy of A is the gain in kinetic energy of B equal to mg h. Is equal to mg into h is equal to half. Is equal to 5 by 2 mg. From this mg will cancel out, r is equal to 1 by 4. Remember, I am not calculating the velocity, but the velocity gained by this. Otherwise, we can do so. What is the velocity gained by B? Loss in potential energy is gained in kinetic energy of this one. And that velocity on reaching here must satisfy root of IRG. And do the same thing and get. Yes, straight away we equated the energy and got the answer in a simple manner. So, okay. So answer is equal to 4 or 3. Next question. Two blocks with 100 gram and 200 gram are attached to ends of a spring A and B shown in figure. Energy stored in A is E and energy stored in B when spring constant K and KB of A and B respectively satisfy the relation. So we are given here 4 Ka is equal to 3 Kb. Now, for the energy stored in A, energy stored in A is E. So what is E? Energy of A. E equal to, in terms of load and extent, spring constant F square by 2K. Okay. E is equal to F square by 2K. What is the load? 0.1 whole squared by 2K. That is our equation number E. Now for B, E dash that we have to find. E dash is equal to F square. Again, formula is the same. 0.2 whole squared by 2 kb. Now 2 by 1 gives dividing. E dash by E equal to 0.2 whole squared by 2 kb into 2 Ka by 0.1 whole squared. It's equal to Ka by Kb into 2 by 1, 2 square 4. Ka by Kb from here is equal to 3 by 4. It's equal to 3 by 4 into 4. So E dash is equal to 3E. E dash is equal to 3E. So, okay. A perfectly inelastic collision, two spheres made same material with the masses 15 kilogram and 25 kilogram move in opposite direction with the speed of 10 and 30 meter per second respectively, strike each other and stick together. Perfect inelastic collision. The rise in temperature. If all the heat produced during the collision is released by these spheres, retained by these spheres, what is the rise in temperature? Now, what we have to, first of all, we have to find out what is the energy loss in this collision. Energy loss. Now, the two spheres, mass is 15 and the other one is 25. And move in opposite direction with the velocity. This is 10. And the other one is minus 30, opposite direction. And stick together to form a single body of mass 35, 40. And velocity v dash. Now we have to find what is v dash. Linear moment conservation. Because the 10 into 15 plus here minus because of minus 25 into 30 is equal to 40 into v dash. This on calculation. $600 equal to 40 into v dash. From this, v dash is equal to 600 by 40 is equal to 15 meter per second. 15 meter per second. Definitely, I am not bothering about sign in which direction they are moving. Not at all important. 15 meter. Next thing, what we have to find, what is the energy lost? What is that energy loss? Total kinetic energy before half m into 15 square. No, I'm sorry. Mass is equal to 15. 15 into 10 square plus half into 25 into 30 square. This is the total kinetic energy minus kinetic energy after collision of total mass is 40 into v dash square 15 square. This is the energy lost. This energy loss on calculation, the energy difference on calculation is found to be 7,500 joule. Now this heat is accepted by the combined body and rise in temperature is there. Energy, and if delta theta is the rise in temperature, then what is the heat required for that MC? Delta theta is equal to this much, M 40 kilogram. M heat equation is MC delta theta. M is equal to 40. See the specific capacity. Specific capacity is given to you as 31 calorie per kilogram. 31 into calorie per kilogram. Calorie. Joule per kilogram we are required into 4.2. 31 into 4.2 into rise in temperature. The heat required, heat energy required to rise for rise temperature delta theta is given by MC delta theta is equal to energy lost during this collision. From this delta theta is equal to 7,500 by 40 into 31 into 4.2. This is approximately 1.44 degrees centigrade. So option is okay. Next, given below R2 statement, an object move from R1 to R2 undergo conservative force field F. The work done is given by minus integral R1 R2 F dot dr. Minus in a conservative force field minus R1 to R2 F dot dr is the potential energy, not work done. Work done is plus R1 to R2 F dot dr, not minus. So this statement is wrong. That statement is wrong. Second one, because this is potential energy change and not work done. Any object moving from one location to another location can follow infinite number of paths. Therefore, the amount of work done by object changes with the path it follows. In a conservative force field, it is not a path function. It depends only on initial and final, and therefore this statement is also wrong. Both statements are wrong. What is the both statement 1 and 2 are false. So this is the answer. A body of mass 2 kg is moving along x direction with that displacement as a function of time given by the net work done the body during interval 2 seconds to 3. Mass is given 2 kg and we are given the displacement function. Now from displacement function we can get the velocity function. So velocity function is given by dx by dt is equal to 2 alpha t plus beta. This is the velocity. And where alpha is equal to 1 is equal to 2t plus 1. This is the velocity function. Now work done. Work done is given by change in kinetic energy half m v2 square minus half m v1 square. Now what is v1? v1 is t is equal to 2 seconds. v1 is equal to 2 into 2 plus 1 is equal to 5. v2 is equal to 3 seconds. 2 into 3 plus 1 is equal to 7. Therefore, change in kind work done is given by half into mass of the body is given to you 2 kg into 7 squared minus 5 squared. And the value on calculation is found to be 24. So the answer is 1. Okay, next one. Potential energy versus distance is given by the graph. Rank various region as per the magnitude of force. At magnitude, they are simply asking. Now we are given potential versus distance graph. You know, F is equal to minus dV by dx or dr. Modulus of force in slope, simply modulus of slope, a graph. We have to see where the slope is more and arrange them. Here you can see that here the slope is maximum, CD. Then AB. Sorry. Here CD first, slope is maximum CD. Then slope is A, not CD, I'm sorry. Slope is maximum with B, here B. BC. Next AB. Then D. Then CD. Now you can see that force BC greater than force AB greater than force DE greater than force at CD. We simply look at the slope and get the answer. So the answer is modulus of force is the slopes. Okay. So this finishes our today's video. Thank you. See you next time.